Welcome to The Explainer. Today, we are unpacking a seriously fascinating insight from Memne HQ about a hidden trap in modern engineering, specifically the architectural dangers of using multiple AI coding agents in your software stack. If you're on an engineering team that's using AI to write code, and let's be real, who isn't these days, this is an absolutely crucial look at how the tools we rely on might actually be working against us.
Okay, let's dive right into this massive problem facing engineering leaders today. We're in this wild era where the very tools meant to speed us up are quietly, almost invisibly, fracturing our code bases. Think about it. 3 years ago, the big question was just, hey, which AI assistant should we standardize on? But today, that question is totally dead. The answer now is that teams are just using all of them. And as we're going to see, when you have multiple AI agents touching the exact same code base, keeping your architectural rules intact turns into a complete logistical nightmare. Seriously, architectural governance just dies at the seams.
So let's look at Section 1, the multi-agent reality and our fragmented workflows. To really understand how fragmented things have gotten, you gotta look at the fan-out effect happening in teams right now. We are absolutely no longer living in a one-tool world. Engineering adoption of AI, it's bottom-up, it's per engineer, and it's per task. You might have one back-end engineer pairing with Claude code in the terminal, relying on this specific markdown file for memory. Meanwhile, you've got a front-end engineer touching up code using Cursor, and they're guided by a totally different rules directory. Then someone else is using GitHub Copilot for inline completions, and maybe your platform team is running a custom bot on an SDK with its own bespoke system prompts. It's crazy. You end up with one single code base, but 5 different proprietary formats. Basically, 5 distinct sources of truth trying to dictate its architectural rules. Now, you might be thinking, well, I'll just manually copy my rules into every format. Write your architecture for Claude, then mirror it to Cursor and Copilot. But that fails so fast. Why? Because each tool interprets, truncates, or prioritizes those rules entirely differently. One might read your rules as the single massive context block, while another only applies them when matching specific files. A third might just aggressively truncate the text to save tokens, so a rule enforced by one tool might be completely dropped by another. On top of that, drift compounds rapidly. Someone updates one file, forgets the other, and suddenly your tools are practically speaking different languages. And here's the real kicker. There is no shared enforcement. Inside each tool, your rules are basically just suggestions. Which brings us to Section 2, the seam problem and structural collisions. So, what exactly happens when these fragmented tools actually intersect? Let's walk through a super common disaster scenario step by step to see how these conflicting instructions create structural collisions. Imagine an engineer prototypes a new service using their favorite interactive editor. Because they're just experimenting, the AI is operating under a fairly relaxed set of rules. Cool, they push their code. Then, step 2, a custom automated bot picks up that exact branch in continuous integration and starts refactoring it. But wait, the bot is running against a much stricter system prompt written by the platform team. Step 3, the human reviewers are now staring at 2 patches that completely disagree on the architectural rules. Both patches look perfectly reasonable in isolation, but the reviewers literally cannot tell which AI agent was operating under which architectural assumption. This isn't just hypothetical, guys. This is a massive structural collision happening in teams every single day. And this brings us to a vital concept, the seam. We define the seam as the boundary point between different AI agents, right where generated code is actually written to disk or proposed as a diff. Inside each individual tool, you really have zero leverage. A language model can misread or just flat out ignore your text blocks. But the seam? That's the magic spot. The seam is the natural enforcement point where governance actually has to live to be effective. It is the one single moment that is exactly the same, regardless of which agent originally produced the code. All right, moving on to Section 3. History solves it. Looking at convergence patterns. If all this chaos sounds a little familiar, well, it's because we've seen this exact movie before. Vendor proliferation always eventually collapses onto a shared standard, leaving vendors to differentiate above that baseline. Think back to the early days of software containers. We had Docker and other platforms fracturing the ecosystem, right up until the Open Container Initiative became the standard in 2017. Docker didn't lose, it just became one compliant implementation among many. We saw the exact same thing happen with application monitoring converging on OpenTelemetry, and with code editors unifying under a single language server protocol. The pattern is always the same. Tools proliferate, incompatibility causes a ton of operational pain, and then a community standard forms. And in the world of AI coding agents, that exciting convergence is just beginning to happen right now. Early efforts are laying the crucial groundwork to help these tools actually talk to each other. For example, you've got the Model Context Protocol, providing a standardized way to expose context, which makes it way easier to query governance rules. Then there are projects like agents.md, giving us a shared portable convention across different environments. And groups like NIST are establishing frameworks for how agents identify and authorize themselves. These are incredible building blocks. But, and it's a big but, these standards are not fully finalized yet. So let's jump to Section 4, agnostic governance or Layer 5 enforcement. Which leads us to the big question, right? What do we do right now? Well, we need to shift to a much safer paradigm. Until those industry standards fully mature, the absolute smartest strategy is to build an agnostic layer above the vendors. Instead of per-tool memory that's constantly duplicated, entirely advisory, and leaves those dangerous seams completely unguarded, we need to move to shared governance memory. This approach is tool agnostic. It serves as a single absolute source of truth. And crucially, it enforces your architectural decisions right at the seam, after the code is generated but before it lands in your codebase. To actually make this work, an agnostic enforcement layer needs 4 distinct properties. First, it requires tool-agnostic representation. That means your architectural decisions are stored in a format completely independent of any one assistant-specific prompt quirks. Second, it must be one canonical store that every agent reads from. You update a rule once and boom, it instantly applies everywhere. Third, pre-generation injection. This ensures that only the relevant, correctly scoped rules are fed into the running agent. And fourth, post-generation enforcement at the seam. This model guarantees that whether a line of code was written by a built-in copilot, a terminal agent, or some standalone app, it gets checked against the exact same set of architectural laws before merging. Finally, Section 5, the cost of lock-in and structural danger.
Beyond the operational chaos of managing all these different formats, there is a much quieter, potentially much more expensive structural danger to per-tool memory. 18 months. 18 months! That is roughly how frequently the dominant AI coding tool changes in this rapidly evolving market.
Seriously, just think about how insanely fast the space moves. Back in 2022, GitHub Copilot was the absolute default everywhere. Then, through 2024, Cursor stormed in and took the interactive coding lead. Fast forward to today, and Claude Code's terminal models have been completely reshaping the picture once again, and more tools are constantly entering the fray. Your codebase, however, is expected to outlive tooling fashion. A service written today is still going to be in production years from now. If you trap your architectural decisions inside whatever vendor happens to be hot this year, it means you'll have to rewrite your entire architectural memory from scratch every single time you switch tools. And you're just left hoping nothing gets lost in translation. But as outlined by our source today, Mime HQ, utilizing an agnostic governance layer means you can swap out any of these agents tomorrow without touching your underlying architectural truth. The tools you use become totally interchangeable, but the governance holding your codebase together remains absolute. This gives you both operational hygiene for today and vital structural insurance for tomorrow. So, we'll leave you with this final provocative thought. As your portfolio of AI agents inevitably grows, is your codebase actually being governed, or is it just surviving until the next tool arrives? Are your architectural decisions genuinely enforced, or are they held hostage by whichever tool happens to be generating the code today? It's an absolutely critical question to answer as we scale our AI engineering stacks. Thank you so much for joining us for this explainer, and we highly recommend checking out the original Manet FK article to dive even deeper into this essential topic. Catch you next time!